Hi everyone, so my name is Rishabh Tarve and welcome to my channel. So today I was going through one of the lead code questions. So let's introduce myself first. So my name is Rishabh Tarve and I am from Function Up School of Technology. I am in my second semester of my college and I am learning DSC in Java language and I'm practicing my problems in lead code. So I was going through the lead code question number 152 and it's outlined the question as the heading for the question as maximum product subarray. So let's break down the question first. It says maximum product subarray. So let's understand what's the meaning of the question at first. So in this question, when we will get down by just outlining the heading of the question, we have to find the maximum product of a subarray. What's in subarray inside an array? A part of an array which consists elements of the same array, but it can be any one of the elements or elements less than the length of the elements. So subarray, a part of that array. We have to find the product and maximum product from that subarray we have to find. And the difficulty level for this question is medium, and the topics covered in this question is array and dynamic programming. Also, let's understand the description of the question. So in this question, we have been given an integer array nums where we have to find a subarray that has the largest product and return the product. So in this question, we have been given an integer array nums. We have to find a subarray. So an array has been given and the name of the array is nums. We have to find a subarray, a part of that array, and that has the largest product and return that product. So we have to find that product and we have to return that product. The test cases are generated so that it's fit in a 32-bit integer. Now let's see the examples at first. So understand the question better. Input 1 has been given here as nums 2, 3, -2, and 4, output 6. So when you will understand how this question will approach and how we'll get through the solution for this question. First, when you get through the question, you have to find the subarray in that portion of the contiguous. The meaning of contiguous, which I'm explaining you here, is that you can't skip an element or you can't jump over an element. You have to take that element inside the array one by one. So you can't leave any of them and find the product. You have to keep going through the array in such a way that you don't leave an element between them and you have to find maximum of them. So here it has been given 2, 3, the subarray of this element nums is the maximum product for this array. Similarly, for the example 2, we have -2, 0, and -1. So it has been given in the question, if you don't have any of the maximum product in the subarray, you can simply return 0. And the result explanation for the example 2 has been given, that cannot be 0 because -2, -1 is not a subarray. You cannot find a you cannot find a subarray in this. So let's approach for this problem at first. So for this question, I want to explain first the brute force approach. What's a brute force approach in this? What we're gonna do, we will initialize a variable. We will iterate through nested loops. Why I'm going to say nested loops? Because one of the loops which you are iterating will keep the records of your element, and the second loop will keep the track of all the elements coming through, and it will find the product of them inside the subarray. So let's understand what I'm talking about. So let's code while I'm explaining to you. So let's take a variable max. I have initialized my variable max with the data type integer. So in the Java programming language, you know that integer is a data type that stores up to the value at a certain integer dot max value, which is something approx in a format. So let's max is equal to. So what you gonna do, clearly you have to take the value. So how you gonna initialize the value of max? So why we are initializing the max variable here? Because we want to return this value at last. So this will be our output. So we will initialize it with the lowest number that can be possible. So the lowest number which can be possible in this is integer dot min value. So let's initialize it with the integer dot min value. Now We have initialized our variable max with the integer dot min value. So the minimum number that can integer can hold, I have given that to the max variable which I have initialized, because we don't know how less the number can be, but the data type which I have initialized cannot leave that number and cannot be less than that number, because the data type can store between that range, and we have given it the minimum value of that data type. Now let's start our loop. So at first, what you have done, you have initialized a variable and given that variable as the value as the minimum which can be possible. Now let's start with a loop. I will explain you why I'm initializing a loop, because it's a brute force approach that first when you can approach for this problem. uh, int I equal to. So what's the approach that came in my mind to solve this problem? Because in this question it has been given that you have to find the maximum product of a subarray. To find the maximum product of a subarray, what you're gonna have to do, you have to take an element and you have to iterate it through whole array. uh, so how you're gonna do that? You have to take the pointer at first. So the first loop is gonna work as a pointer for me, and the second loop inside that will be working as the keep tracking of the numbers after that coming element. So now let's initialize the another variable. Current value is equal to 1. So I've initialized a basic and a predefined value to my variable current product. So I have given the name of my variable as current product. So basically what we are going to do here, as we have initialized our variable, and the first index in that array will store the first integer in that, and we have initialized a variable as current product and given the data type as integer. What it's gonna do? Now it will take the first index of that number and it will store inside the I integer which we have initialized. It will store that value. Now we will use a nested loop inside that. So at first, we have initialized a loop, for loop. We have given three parameters inside them: the initialization, condition, and increment, decrement. I have initialized the first loop from 0 because we want all the elements from the array to be considered. Then we will iterate it till the length of that element, and also I plus plus, because in this loop it is gonna iterate every time when the execution will happen. Now, coming to the variable which I have initialized, talking about the second loop which I have initialized. Now, second loop, what is going to do? The first loop is taking the record till the elements which we have got the current product. Now, every time that first loop is giving certain index, it will iterate till the length of that array in the second loop. And then second loop, what it is going to do, it simply update my value every time. So simply both the loops are doing. This is the brute force approach that someone can initially think of. You will iterate two loops. One will keep the record of the first index, and the second loop will keep updating the variable which you have initialized with 1. It will keep updating till you get your maximum product. So how you will get your maximum product? To get the maximum product, the variable which you have initialized at first, it will be get updated. How it will get updated? By using the math.max. By using the math.max, what it's gonna do, it will so math max, the variable which you have initialized max, then math.max, current product and max, both will get compared. Uh, whichever will be the suitable one will get. Let's check for our code is working or not. So all the test cases for the brute force approach, we can say that the test cases have been passed. But talking about the time complexity and space complexity in this, sorry for that. But talking about time and space complexity, we have used loops, and we have used nested loops that will take too much of time complexity, and using for too much of nested loop will give you an big O n cube time complexity, because you are iterating to every time when you are uh, updating your first loop with a track record of next index. When you are not getting any max product, every time this loop will iterate and creating a lot of time complexity for this. Now let's submit our code. So as you can see, the result processed by LeetCode is being shown to you, but the runtime, which you can see, the time complexity is taking 278 ms, which is quite a lot. But the talking about space complexity, you have only initialized a single variable max and a current product. So these two are the only variable which you have initialized. So space complexity is not an issue in this question. Space complexity is big O1, which is linear. But the uh, time complexity is big O n cube, because you have used nested loops. Now let's approach for a efficient solution for this. So let's try for a efficient code in this. What you wanna do? Let's start. So how you gonna approach for this problem in an efficient way? What you gonna do to here? You will initialize four variables. Uh, let's say you will initialize four variables as minimum so far, maximum product, and a temp. So how we will approach for in this way? You will update minimum so far, maximum so far, and at first you will initialize all those variables with the num 0 or the first element of your array. Then every time there will be four conditions on which you will update your minimum so far and maximum so far. Then the variable which I have told you, the third variable, which is maximum product, will be the maximum product, and the result or the which we will return, it will store our maximum product for that array. Talking about minimum so far and maximum so far, we'll keep the track of what we have got till now, the maximum product, and what we have got till now, minimum product. There will be four cases. The first case will be if the current element, what we are talking about current element, the current iteration with the current index or the current element of that array, the current index, the I, considering our variable I as the index. So the current element, if that is negative, then what we will do, let's suppose we have our minimum so far is in the negative value. So what it simply does, when you have the minimum so far as negative, then you will swipe the places of maximum so far and minimum so far. Then you have the second case as if the uh, current element is 0. Then in that case, what you're going to do, you will reset minimum so far and maximum so far. So talking this in a brief manner, let's explain you through the code. So at first, take for an example, if our array is empty. So for that, you have to check, give the condition if nums double equal to null, or nums dot length equal to 0. Then in this case, you simply return 0. If any of the case will happen, if we got an empty array, or if we got an null array, what we're going to do, will simply return 0. Now let's talking about the case. Let's take few variables. The first variable we have is minimum so far. I've given the abbreviated form of minimum so far. It will be easy for you to write down. Then the next case we have is maximum so far. Maximum so far. We have also initialized this to the first index of our array. Then we have maximum product. Maximum, what maximum product? So talking about maximum product will be same as max so far, which we have iterated or which we have updated. So in this, we will update our maximum product with the maximum so far, which we have initialized. So it will store the same value which we have with the maximum so far. So we have got our three variables which we have assigned. We have also checked for the condition if our array is empty or not. Now let's iterate a loop, start a loop. and this loop will start from 1. Why we are starting from 1? Because the variables which we have initialized is considering from the first index of that array. So in this case, we are starting our loop from the first index, because uh, the 0th index of that array is already in the variable which we have initialized. So there is no need to start a loop for the 0th index. We will start from the first index. Now let's check our code. We will check till nums.length I plus plus. So here we have initialized the loop. We have initialized few variables. We have checked for our empty cases, and if the length, if our array is empty, we will return 0. We have also initialized few variables and started the loop. Now what's the next step? We have talked about few cases which I was earlier explaining in the descriptive form. Let's understand in the coding format. If our nums I less than 0, if our nums I is less than 0, so in that case, what you want to do? We will again initialize the variable temp, and we will update or initialize the variable which we have initialized temp will take the value of our maximum so far. I will explain you why we have done so. Now we will update our variable maximum so far with the minimum so far. What's the minimum so far? Why we are swiping the values? Let me code first. I will explain you. Minimum so far. Temp. So in this case, what's happening? If we encounter the current element, I'm talking about the current iteration of the element in that array. So here the current element is nums_i, and here whenever our current element is negative, what's going to happen is the maximum so far is not in the scenario, because the minimum so far here in the comes in picture. Because what's going to happen, minimum so far, let's consider it to be in the least number or in the negative form. If that's going to happen, we can simply swipe the value with the maximum so far, and the current element will get multiplied with the nums_i. So in that case, the least number will get converted to the max number. So this case is for those conditions where our minimum so far which we have iterated in is in the negative number, and the current element which you are iterating through the loop is also a negative number. When two negative number will get multiplied, we will get a number that is simply the max number, might be the max number. So we will simply swipe the value of minimum so far and maximum so far. This can be the case, but there are also cases when you will update your minimum so far and maximum so far. Now let's talk about those cases as well. Minimum so far, when they will update it. Let's take the case of maximum so far first. Maximum so far is equal to math.max nums j nums_i and max so so far multiplied by nums_i. Let me code first, so after that I will explain. Let's just copy this. So we have to again write it, but just we have to update our value. So here we have the condition of minimum so far, and this will be math.min. So at first I have talked about four conditions. Four conditions can be the current element can be negative. Second condition, current element can be 0, which we have taken here. And the third condition, current element can be positive. And the minimum so far will be negative. So the first case has been handled. If the current element is negative. The second case and third case is consisting in this: if the current element is positive and our minimum so far is non-negative, then in that case the maximum so far is the current biggest number. So we will multiply it with that. And why we are using math.max? Because it will update the value. Then we have minimum so far, that math.min num psi max so far multiplied by num psi. So max so far will be updated with math.max, and min so far will be updated with math.min, because we want the minimum number in min so far. So every time we get a number which is negative, gets updated, and in that case what's going to happen, we will get the uh, maximum number, because when two negative numbers will get multiplied, we will get a max positive number. Now let's check our condition, that max product is equal to math.max max product, and our max so far. Now let's return our max product. Check for our code. So here we have lagged something in the line 9. And I less than, here the less than sign is being used double times. Let's correct that. Now let's again. So here we have also missed that symbol for the termination. Then we have, what's the error here? Means of our variable cannot find symbol. So f is being small here. Let's correct that as well. So in this approach, our test cases have been passed. All the test cases, at least till now. Now let's check whether it gets submitted or not. So this is not handling the case of -4, -3, and -2, where the expected is 72 and output is 72 and expected is 12. So our condition is giving it's the 72. So let's check for this issue. So the error we have is all the negative numbers. So let's check for the negative number where we have handled so far, min so far. For temp, max so far is, so here is the issue. The min so far is being updated with the max so far, so that's not correct. So I have corrected it. Now let's check. So all the test cases have been passed. So this is the most efficient code that can be possible for this solution, because in this we have only initialized one variable, that is few variables, and those are all linear format. So the time space complexity will be big O1 and the time complexity will be big O(n), because we are iterating big O(n), because we are iterating the loop only one time, and the subarray is being calculated with the maximum product. So what's really going to happen in this approach? We have solved for the edge cases. If our array will be null or the elements inside it will be 0, we have returned directly 0 in the first scenario. Then we have initialized few variables. We have checked for 3 conditions where my current element is less than 0. If it's negative, it is 0. If it's positive. For all those, I have updated my max so far and min so far. So by all these approaches, our conditions have been passed. So every time we updated our value with the max product, and then max product and max of r will be compared using the math.max, because max product is containing the value after swiping it with the max of r. So in this way, our approach is being completed, and this is the most efficient code for this problem. So hope you like this, and that's all for this video. Thank you.